All right, I've got our quad R9700 system here put together. It's running ROCm, VLLM, Docker, the whole stack. And yeah, it's really singing 1200 watts of GPU in here. It's no secret that I think one of the best defenses of our future is the ability to run AI locally. And when you do that, an entire universe of possibility opens up. Full open source models, open weights. That means you can do realignment, customization. You can do things yourself way outside the box. Things you're never ever going to be able to do if Elon Musk or Sam Altman or the New York Times were forced to be in the same room with you while you're talking to your AI. Wait, the New York Times in the same room? What? Wait, that was a thing, yes. That's all the more reason to go full local or go home. Now, look at this machine. 4 Radeon AI Pro R9700s. It's a beautiful thing. But here's the catch. It's just not enough to jam a bunch of GPUs into a box and call it done. If you want to learn why we made some of the choices that we did in the build, there's a separate video for that. You can also come to the Level 1 forums. Q&A, builds are a lot of fun. Once you start running real services, things other people depend on, you need some safeties, health checks, redundancy, a way to survive failures without everything falling over. So what I want to show you today is a setup that gives you some perspective on approaching that kind of thing in general, and a really good specific example, how to build those safeties, how to think about the let's call it the computer janitor side of running local AI. In fact, you can tell your boss that you're watching a video on AI and they'll probably make them happy, right? Because AI everything. But honestly, this video has very little to do with AI. But it is, however, A-level computer janitoring. So that's exciting. So let's ground this in a real world use case. Imagine that this is a code assist server for a small dev team. This box, as you see it, costs about 10 grand at the time that I'm doing this video, and it'll peak at around 2,600 tokens per second for token generation in our benchmarks and with the model that we're using. Now on paper, that's fantastic. But here's the problem. You don't just hook people up directly to VLLM, at least not if you want this to behave like a service instead of a science project. You don't want to foist science projects on people. You know, machine learning stuff is still bleeding edge. Models crash, drivers hiccup. Someone pastes a massive prompt at the worst possible time, and when that happens, you don't want the entire team staring at a broken endpoint. And that's where this setup, the software side of this, really starts to matter. So at its core, the AI stuff, it's just an API. Your code editor, Visual Studio Code, Cursor, NeoVim, Aider, Vigor, whatever, is talking to an endpoint. OpenWebUI or Ollama that you may be familiar with, it's a front end talking to an API. Here's the thing though, there's no reason that your users need to talk directly to the VLLM endpoint. This is up and running with ROCm and the setup is clean, but how do you handle a GPU dropping out? We got 4 GPUs. We need a service wrapper. Enter HAProxy. Yeah, I know HAProxy doesn't sound like sexy or amazing, but it's incredibly good at exactly the problem we have here. HAProxy gives me one stable endpoint, health checks, automatic failover, load balancing, sticky sessions. That's important for cache locality mostly, and it actually works. HAProxy is not new software. It's tried and true. It's a known quantity. Now, from your code editor's view, there is one API. Behind the scenes, HAProxy decides where the request goes. Nothing about this architecture requires one machine with 4 GPUs as I've done here. HAProxy does not care. Remember our 4 DGX Spark cluster video that I did? Prompt processing on those is blazingly fast. I've even been experimenting with making a hybrid cluster where we're doing, ROCm and CUDA in the same cluster. But that's not really the subject of this video. You don't need a monster system on day one. You can grow into whatever you need, and the machines and the capacity and the clients never really need to know that. So here's the HAProxy script on the Level 1 Techs forum, and it has a lot of hard-won janitorial knowledge in it. Our own Patrick on the forum put this together, and as we were chatting about it, thinking about how we wanted to do this and make some interesting content, it's kind of AI adjacent that we could show off this setup and work backward, from what we've done. And so there's a lot of really cool knowledge in this. So this script has a lot of really cool stuff in it. And this is the computer janitoring stuff that has nothing to do with AI or VLLM. Things like CPU governors, GPU power profiles, disabling transparent huge pages. There's a little bit of an asterisk to that. You need those for virtual machines, but there's no reason you can't pre-allocate them. None of this kind of thing is really super exciting. But all of this matters under load. If you skip this, what you get is a situation where like, oh, well, it worked fine yesterday, and today it's haunted. I can't use my endpoint. So yes, this script does a lot of boring things, but that's intentional. So why go through all of the effort to put something up like this when VLLM works? Because once you have a reliable local endpoint, you can actually use it. For me, it's things like code assistance for a small dev team, helping with unit tests, refactor, DevOps automation, because you can ask it lots of DevOps questions, even writing the glue scripts like this one that is on the forum. And here's the important part. It's always there. There's no rate limits. There's no surprise policy changes. There's no, oh, this feature is now premium. It's just a tool that you own. A tool that you own. So this is what it looks like running install after we've got our ROCm set up. Now, setting up ROCm is fun. Fortunately, George, I don't know how you say it exactly. There's a link to this awesome dude's GitHub that has moved heaven and earth for ROCm related things. And there's tons and tons of useful stuff for a ROCm context on his GitHub. So follow the issue tracker and follow the stuff that he's working on to know the ground truth of what's going on. And so with our script done, it's like four RDNA GPUs have been detected, AMD Radeon AI Pro 9700 with ROCm VLLM support. Woo! If we do Docker logs, we can see that our containers are coming up. We've got 2 containers. The script sets up 2 GPUs on each container and HAProxy for the configuration there. Now remember, you can run one Docker container here and another Docker container somewhere else over the network. You can have 2 physical machines. It's completely fine. For the model, we are using the special model that we're working on, and this is going to be a different video because I think this is gonna it's a retrain of GPT-OSS 20B, but I think it's going to blow the doors off of how useful GPT-OSS 20B is, and I'm going to try to bum some GPU resources to do the same kind of training with GPT-OSS 120B, because there's some serious functionality that you can unlock in GPT-OSS 20B with some fine-tuning, but that's not subject to this video. That doesn't have anything. That's just the service that we're running. We're talking about the plumbing and janitorial stuff for this video. And so if you go to the IP address of your system, :8000/v1, you can see that, hey, the API is there, and that is what you can point your editor at. But it's actually serviced by HAProxy before it's handed off to VLLM or, your AI backend, in other words. HAProxy is sitting in the middle. So there's a lot of glue in here to help you fix up ROCm in your ROCm version. ROCm 6.4 on RDNA can be pretty stable, but again, this is just hard-won engineering stuff in here. There's also the fact that your GPUs can go to sleep, and that is not necessarily an AMD-only problem. And so there's a glue in here that is like, hey, GPU, wake up, do this. And so the CPU doesn't go to sleep. Now for HAProxy, it's encrypted. If you're just using, like llama.cpp or VLLM raw, it doesn't give you TLS encryption, which means that if somebody's running Wireshark, they can sniff the network. Well, not a switch network, but they could sniff the network and capture the packets and see what you're doing. Somebody could be nosy on the network, in other words. HAProxy supports HTTPS encryption, and so this is going to use a generated certificate, which you'll get a certificate warning for. But if it is public on the internet, or if it's reachable, or you have a like a wildcard certificate or something like that, or you have an internal certificate server like you're on Active Directory or something like that, and your machines trust a root cert, you can substitute that in here. There's some environment variables there you can edit, but this is going to create a self-signed TLS certificate for HAProxy, which is nice because it means that your interactions and your users' interactions or code editor interaction from their machines to this machine will be encrypted, TLS encrypted. And then finally, we see some stuff in the script that is outputting the stuff that you saw when I first ran it. It's like, okay, these are the GPUs I detected, just stuff to make sure that it is, I don't want to say that. The script output, this is the stuff that outputs the stuff that you saw from the script to let you know that the state of what the script observed makes sense for the reality that you're in and your GPUs that you have and that sort of thing. Because obviously if the GPU's missing or the versions are wrong or something like that, you can see that in the output and take corrective actions or come to the forum for troubleshooting. If we look at our HAProxy configuration, we see that it's on 8000, and if we go to the IP address, :8000/v1 for our API, detail not found, it's a JSON response. This is the URL you can give your front end. I can on another system, I can run OpenWebUI and point it at this system. I can also run OpenWebUI on this system, whatever we want to do. That's what I've done. I'm using the Persona Epsilon. There's several of these personas are on Hugging Face. This would also work fine with Quinn. And I've set the reasoning to low on this system, so you can see there's an example system prompt message there, which I need to do this a different way because OpenWebUI, I'm sort of cheating a little bit here with the way that OpenWebUI does this. You could actually set this up in the connection a little differently. And also these personas have D&D character alignment, which is unique to us. So if you would like a GLaDOS style, you know, if you want lawful evil or chaotic evil as your AI assistant, you could totally do that. If you ask it what the content policy is, it will say none. And in terms of plumbing, if we run NVTop, we can see that our GPUs are getting full utilization and nearly full memory use, which is great to see because we get that deep context. And the deep context is important for running, complicated code bases, not queries like howdy. But I'll leave that up to you. Experiment with this, comment in the forum so other people can see, and let us know how we did. And you can always fall back on running a Quinn model or really anything from Hugging Face that'll fit within the geometry of the machine that you have. If you might permit me to ramble for just a moment, I've got a sneaky engagement challenge for you. So, you just watched a whole video that isn't really about AI, it's just an AI use case. AI is the example, but what this video is really about is about building a service pattern, Docker and HAProxy, health checks, redundancy, and ownership of that stack. And that pattern applies to everything, APIs, websites, Node, Rust, Go, whatever you build. Now here's the challenge. Scroll in the comments and notice how quickly some people jump to, ugh, no more AI videos. I mean, I get where that negativity is coming from, but the frustration is often aimed at the wrong thing. Targeting AI or learning about AI or anything that smells like this new AI thing is not really the problem. The problem is that middlemen have a new and powerful tool, AI, to subvert reasonableness and common sense. And that is what's deserving of the negativity and strong negative reactions. Middlemen cause what Cory Doctorow calls enshittification. And yes, that part is real. You will not experience enshittification if you are actually in control of your technology, however. Software running on your hardware, models you host, configuration you own. Once there's a gatekeeper between you and the technology, it will inevitably change for the worse. And the less you can do about it, the worse it will become. And look, I'm right there with you on the negativity. If Sam, Elon, or Zuck are in the room when I'm working on AI tooling, I'm out. What astonishes me though, is how people often miss that this exact same dynamic already exists all over technology. It's basic ideas like property rights start to fall apart. Right to repair, right to format shift or time shift your own media. Oh no, Apple's trying to protect my data. Apple's code signing certificates, App Store approval, locked boot chains. You're not gonna be able to run code that you own on your device. Everybody laughs at Microsoft for jamming Copilot into everything. But Apple and Microsoft are middlemen in exactly the same way. And if a choice is good for the user, but not for the company, they will never make that choice. What we actually need to build is build a world without middlemen, personal sovereignty over your technology. And the design pattern and knowledge shared here in this video is about exactly that. Yes, AI is disruptive, and it will only be a positive disruption if enough of it is built, run, and shaped by people who are building with no middlemen in mind, no ulterior motive. The AI model I showed here, which will be in a future video, but you can download now, surprised me with how free it has become, because it's a customized model where we've done some fun stuff. This mindset, software that answers to exactly one master you, is the original philosophical goal of open source, and I will be glad to put in the work to help us get there, one video at a time. But skipping the philosophy lecture, I think we can all agree that cogito ergo sum is on shaky ground at best these days. And what's left is A-list computer janitoring as we, build that on. This setup would be pretty robust and good for a small team doing code assist with a deep context. 2200 tokens per second is blazing fast. But with that deep context, that performance is gonna fall off a bit. And so that's why we did that. Check out the forums for details on that and other projects others have been working on with this kind of thing. I mean, 128 gigs of VRAM in a system like this across 4 GPUs with ROCm, well, this is a pretty fun project with pretty great value for tokens per dollar. But the learnings here will apply to basically anything that you can run a platform on. And the deep context lets you have a large, complicated code base and still have relatively coherent answers from the model that you're running. And so this is a good discussion topic, and this is a good, fun engagement thing, and this is a fun, interesting thing to look at project-wise, as we do here at Level 1 Techs. I'm Wendell, this is Level 1. If you have any questions, or we want to do something with this on the forum or whatever, hit me up. I got to do a couple more things with this, and then get the two of these 4 GPUs off to our winners who are working on projects of their own, which is fun and exciting, because yeah. And just before I take us out, I wanted to share the awesome thread for contest entrants on the Level 1 Techs forum. You should check it out because these are all fun, exciting use cases for using this kind of a machine. And there's 2 winners. One of them is the Truest Repairman, who is working on segmentation of medical data, whole brain imaging data. They recently got their PhD. This seemed like a really cool use case. We got some engagement from, you know, the OP, you know, researcher people that are helping us sort of change the universe, Ubergarm on the forum. Lots of fun models and things like that. And then the other winner is Exigfedum, I don't know how you say that. This is the IT director for Rochester Hills Public Library. It's a non-profit public library system, and libraries support, you know, knowledge and getting knowledge out there. And so, like, this would be a fun little sort of project to play with LLMs and have them run locally and do that kind of thing. And an SQL query assistant. Yes, I tried that on this system using the relatively small model, and it does a dang fine job helping you come up with queries for either MySQL or PostgreSQL. So both of these use cases are great, but there were tons and tons of awesome projects on that thread on the Level 1 forum. I continue to be impressed and humbled by how many people out there are actually doing useful things with all of the explosion of new tooling that is available, and especially in a local context. It's awesome. And also big thanks to AMD for sending me these so that I can give them away. I need to get more. You got any scratch and dent hiding under the desk in there? I could pick some more projects. It doesn't have to be packaged. It can have some mileage on it. These certainly have some mileage on it. Get those out to the winners. Anyway, I'm Wendell, Level 1. I'm signing out. You can find me in the Level 1 forums.